So for this next question, it says state the domain again. This time we want it in set notation. So set notation is the one with the squigglies. X, give me some condition, and then tell me what numbers does X belong to. And normally it's all going to be all real numbers unless we have a specific list, we have a step function, etc. And so that's kind of what we're looking for. So we look at my equation and notice that it's irrational, it's a fraction, right? So the only bad things that can happen, or the only part that is not defined to be, is when the denominator is equal to 0. So the first thing we're going to do is figure out when is it equal to 0. And the reason we want to figure out when the bottom part is equal to 0 is so that we can know that, hey, if your X value is this, the bottom is going to be 0, which means you can't do anything. It's going to be undefined. So the reason we want to know where it happens is so that we can avoid happening, right? So we can avoid that happening. And so we have x squared plus 6x plus 9. So in other words, we're setting the denominator equal to 0, and that means we're going to have to factor. So once again, there's many ways to factor. But in this case, because my a value is 1, we can jump straight to our factor. So we're looking for two numbers that multiply to 9, right? So two numbers that multiply to 9, or a is 1, c is 9, so 9. And those same numbers have to add up to my b value, which in this case is positive 6. And so those numbers are 3 and 3. Because if you're multiplying, you get 9. If you add them, you get 6. So I have x plus 3 and x plus 3. So this kind of makes it easy because that means that I have one solution, and that is -3. So what that tells me is that I know that if I plug in the x value of -3, I'm going to get 0 in the denominator, which I don't want 0 in the denominator. And so I'm going to avoid that number, right? So I can choose any number that I want as long as I don't choose 0. And so if I write my domain in set notation, we have x as a variable, my condition, right? So what don't I want? Well, I want to choose any number as long as it is not -3, and then x can be any real number, right? As long as you're not 3. And then we're good. So for this next problem, next 3 problems is saying determine whether the function is even, odd, or neither. So whether we're looking for the function to be even or odd or actually neither, we kind of started the same, right? So if we're looking for the function to be even, if we're looking for the function to be odd. So if we're looking for the function to be even, we take every x value, replace it with -x, and if we get the original function, then it's considered to be even. If we do the same thing and we end up that everything changes by a negative compared to the original one, then it's odd. And if it's neither one of these, then it's obviously neither, right? So that's kind of what we're looking for. So for this first one, if we replace x with -x and simplify, well, since x is being raised to an even exponent, that means that I'm going to end up getting the same thing, because I'm going to end up getting a positive x number out of it. And so here I end up with the original equation, right? So what I really have here is g of -x is equal to g of x, because that's the original one. And so in this case, I can conclude that that is even, right? And that's my work leading to my answer. Looking at the second one, we have f of -x, because again, it's the same step. We're going to take in x, replace it with -x. We're going to simplify, right? So here we have a negative number raised to an odd number exponent, which means we're going to end up with a negative. And then we have a negative times a negative, which means we have a positive x. Now, even though it looks like it kind of switch, or it's not, the whole thing didn't switch, we had to look at what we started. We started with a positive and then a negative, and we are ending with a negative and a positive, which indicates that it all switched by a negative, right? And so if you want to be a little bit more technically here, I can factor out a negative parentheses, and I have x cubed minus 6x. And if you notice, this is exactly f of x, right? So really, if you want to go the extra mile, I have f of -x is equal to negative f of x, which is enough to show that it is an odd function. Lastly, I have h of negative x, and if I plug in, or I replace or substitute x with negative x plus 1, I end up with negative 4x cubed plus 1. Now, it kind of looks like it might be like the other one, but if you notice, we started with positive, and then we're ending up with a negative and a positive, right? So it's either all or nothing. Either they all change signs or they don't. So in this case, since only half of them are changing, then we can conclude that it is neither.